Good morning, everyone. Welcome to Jonas Research. Today, we are going to talk about t-test. So, basically, what t-test is talking about is they are just statistical method which we use to determine whether there's a significant difference between means. The word here is significant. You can choose to determine the difference between the means, but meanwhile it's not significantly what accepted. So t-test is normally used for those kind of analysis. If you want to know whether the means are what difference or not, whether there's a difference between the means or not, that's what we use t-test. I hope you already know t-test. We have the one sample, we have the two sample, whether it's dependent or independent too as well. So today we are just going to look about all of that in R. We have already learned it in class, but we have not yet to practice it in R as well. So today we are just going to quickly know how you can do that in R. So I'll just generate any random data that I want using a set seed. You already know the meaning of the set seed in our previous video. So I just go around. I just want to generate, before training, maybe if you are talking about military training, before and after, what's actually happening. We just want to know the mean, whether they are all the same or different. So I just use the R norm to generate any data of my type that I want. So before the training, let's see, this is how the data generated for me, and after training too, let's see, this is how the data was also generated for me. So this is what I have. So I just want to, for the two sample, you're supposed to get two groups. So I just generate any random two numbers as well for group A. I've named the first one group A and the second one group B. So let's see the values for group A. Let's see the values for group A. Let's see the values for group B. Also see the values for group B as well. So let's go straight to the one sample t-test. So we already know one sample t-test. We are using two tail for our first example. We have one tail and two tail. As well. So this one, we just want to know whether the mean of just our data. We already have, let's say, one sample. That means you already have one sample. You have only one sample. You don't have two samples to compare. You already have one sample. Do you get me? So this purpose is we want to know whether what the person is trying to say, whether its mean is 70, whether it's true or false. So that's the null hypothesis. That's the person's hypothetical, what do you call it, conclusion. Oh, the mean is already what, 70. So you are yet to prove whether the mean is correct or wrong. So you also be the alternative. So we already have alpha value, which is 0.05. That's what R normally works with. I will just give you the one in what 0.0 at its default. You can choose to change it as well. So our p value, let's run it. So we use the t.test. So we are using the before data. So t.test, to find, then use the mu to tell her that we are the mean. Yes, what, 70. They said the mean is equal to what, 70. So run it, and you can see this is the outcome, so the output. So you can see the p-value over here. The p-value is 0.004. I already know that if the p-value is less than an alpha, normally at default I say is what, this one is 95% confidence interval. So it means that the alpha value is what, 0.05. The alpha value is telling us how we can draw our conclusion to. So you can see that the p-value is less than 0.05. So this time we will what, reject H naught, which is the null hypothesis, and conclude that the mean is not what, 70. And we conclude that the mean is not what, 70. So you can do this in your job field if you want to know whether the mean, there's a previous claim that at this time this is what actually happened. So you can use the data to prove that, oh no, it's that maybe it has changed due to this, it has changed due to this, this kind of, or even weather forecasting as well. So let's go straight to our two sample t-test. We have the independent and we have the dependent. So when we say independent t-test, let me just give you a summary of it. The independent t-test is rather talking about you having two samples, from different, what do you call it, people. Maybe group A is about maybe those in statistics, group B is about those in so there are two different things, and we just want to know whether the mean of A and B are the same. So basically that's what is it. So this one we use the t-test. All of them use the t-test. So for our group A, our group B, and with the independent t-test, because they are from different sample, we sometimes have to assume whether the variance of group A and group B, they are all the same, or whether the variance of group A and group B, they are what different. So our first assumption will be var dot equal. So when the variance are equal and say true, that's for our first one. You see our outcome. We normally use the p-value for conclusion. Yeah. So our p-value is what? 0.1718. So you can see that the p-value is what? Greater than our alpha value. So this time you fail to reject the h naught, which is the mean of A is equals to what? The mean of what? B. You get me? Yeah. So the mean of A is what? Equal to what? The mean of what? B as well. So that one is for our independent t-test. Let's do for if the variance are what? Different. That is 0.1724. You get me? Yeah, 0.1724 is basically, sometimes it will give you the same. If I say 0.1718, this one is 0.1724. They're different as well, but sometimes they give you the same. So here, this one too, the p-value is what? Greater than 0.05. So you fail to reject h naught and conclude that the mean of group A and the mean of that of group B, assuming that the variance are what? False, the variance are different, so the means are what? The same. That's for the independent. And the dependent, normally the dependent, we call it paired t-test. Paired t-test. That's when the sample are all the same but of different types. Maybe before there's an election, this is the kind of thing what is going on, and after, the same people before and after, maybe in a medical trial to us, what they can use in a medical trial. Maybe before, this is how the condition of the people, after giving them the drugs, this is the condition of the people. So it's just before and after. They get me? So we are not just changing the people, they are just the same people that we are using for our data analysis as well. So you use the t-test, your before data, after data, and you tell R that you are using paired. So you say paired is equals to what? True. So basically this will tell R that you're using the paired data. You can see that. So we tell you paired what? T-test. So this is our p-value is what? 1.601 euros a power. So this is basically 0. When you like calculator, you get 0.00000 blah blah. So it is less than our 0.05. So we reject h naught and we conclude that the mean before training and mean after training are what? Different. So this means that there is an improvement in a whether there's an improvement or there's a decrease in your data as well, whether the before it wasn't going on or after it went on well or something like that. So I decided to plot it using the box plot just to give you the difference of how it is. So that for group A, that for group B. In using set dot seed, sometimes the number you generate might be different. So during your practice, the number you'll be generating might be different, because set dot seed just generates any random number for everyone. So it might be different with the output, but just that the conclusion you're supposed to know how to draw the conclusion. If the p-value is less than 0.05, you reject h naught. If it is greater than, you fail to reject h naught. So basically that's what t-test is talking about. In our next video, we are going to know how we can do that in the job field as well, just getting data and be working with it. So thank you, and God willing, subscribe and like so that you can see the next video. Thank you.